Okay, so you ready? Today's date 10/12/17. So our Common Core standard, what we're going to be doing is we're going to be graphing systems of inequalities. Okay? We're going to graph systems of inequalities. Okay, go and write that down. And what we want to do is this. We know that we're going to shade and we're going to shade. We're going to shade two different regions, and that's why I suggested maybe we'd use colored pencils, right? So I'm going to use maybe, let's try blue and, I've got orange, okay? So let me do, first of all, the first equation in blue. Okay, we'll start at 4, right? 1, 2, 3, 4, like we always do. We're going to go down 2 over 1, down 2 over 1, down 2 over 1, right? Solid line, I would agree with solid line because it's got a little equal sign there, right? So I'm going to go ahead and draw my line in, solid line. Okay, simple so far. Am I going slowly enough? It says less than or equal to, so I shade below, right? And that is the solution. All of these points, every single one of those points that we shade, is a solution to the first graph. Every single one of those points is a solution because they're all less than or equal to the line, okay? But we got a second line, so let's put the second line in. The second line starts at 3. Up 1 over 1, up 1 over 1, up 1 over. And this is a dash line because there's no equal sign. Dash line, right? And then I'm going to shade less than, I'm going to shade everything below, okay? Oh my goodness. Well, how about down here? And then, sorry about that, up 1 over 1. Sorry guys, I guess. Good thing I'm all right on shading because it's going to shade there anyway, right? Whew. Thanks you guys. I got glasses on, glasses off. I really can't see, can I? So, in one region, we have an overlap, okay? And that's, I want a darker color. Let's see, let's make green. So in this region here, they overlap. So that's the region that satisfies both graphs, okay? Anything in here is going to satisfy both, okay? So I want us to test a point. So any point within the overlapping area should work for both. So you can pick any point, but what do you think would be the easiest point to choose? 0, 0. Guys agree? Let's just choose 0, 0. So test a point. So we can pick any point around here, but let's pick 0, 0. So to test it, we're going to put 0 in for x and 0 in for y. So I'd have on the first one 0 is less than or equal to -2 times 0 plus 4. All right, so I just plugged in 0 for x and 0 for y just to test my region so that I get 0 is less than or equal to 4, and that's definitely true. Okay, but it has to be true for both, right? To test the region, that point has to work for both systems. So I'll plug 0, 0 in for the second equation. I'll have 0 is greater than 0 minus 3, and I get 0 is greater than -3, and that's true also. So all we've done is shown that any point within that region gives us a true statement for both systems, okay? Pretty easy? Yeah, I don't think we're going to have any troubles with this today. I think it's going to be pretty easy for everybody, okay? In fact, Caleb's already moving ahead. Good for you. Okay, number 2, y is less than or equal to 4. Go straight across, horizontal, right? Let me put that in blue. So I'll go up to 4. 1, 2, 3, 4. Right? And I want it to be less than or equal to, so solid. I shade everything less than, right? It's a nice, easy lesson. You guys will like this one today. But the second equation, we're going to have to solve for it, right? So I'm going to go ahead and do a little bit of math. So I need to solve for y. And I have to be careful because I will eventually divide by a negative. I will. I'm going to have to divide by a -2 eventually. So I'm going to make sure I turn the sign. But first, let's go minus 4x, right? And I'll have a -2y is less than 6 minus 4x, right? And then I'll divide by -2 all the way through, all the way through. And I have y is, turn the sign, right? Turn the sign because I divided by a -3 plus 2 over 1 x. Okay, now I'm ready to graph this one. So I'll graph this one in orange. And I'll start at -3, not 3. And I'll go up 2 over 1, up 2 over 1, up 2 over 1. It's going to be a dashed line because there's no equal sign, right? And shade greater than, so I'm going to shade all of this up here. And again, what we're looking for is the overlapping region because those are the points, all the points that work for both systems. We don't need to test a point. I'm pretty sure we know what we're doing. So I'm just going to make that region darker than the rest. Do that in green. How's that? I really like the colored pencils. I think it helps see it. All right. Okay. Hi, Kenzie. So let's look at the third one. Okay. So graph this. Now I got 4 things. So let me find a 4th color. How about that one and that one? Do I have a red in here? I don't know. Oh, I've got a pretty fuchsia. Okay, here we go. So let's do x is greater than or equal to -2. Okay. Right. Right on -2 for the x, and greater than is shade all of this. So I like the colored pencils. For me personally, it makes it easier to find where all the colors overlap. And I kind of go light at first so I can start to see how they overlap. And then the second one is going to be x is less than or equal to 3. So let me put that in orange. So I'm going to have 3 here, right? And I shade this way. So right now I'm in between. I'm shading in between. So all of my solutions so far is in here. Let's take a look, and we'll do y is greater than or equal to -x plus 1. I'm going to do in blue. So 1, down 1 over 1, down 1 over 1, down 1 over 1, right? Okay, and then I'm going to get shade above, greater than or equal to, so I shade above. Okay. And then finally, oh, how about dark blue? No, yeah, let's do dark blue. Less than or equal to 4. So what I'm going to get in the end, when I shade this down, right, less than or equal to, is I'm going to get kind of a little trapezoid, aren't I? I'm going to get a trapezoid right in there. It's a little trapezoid. You guys see that? And it has corner points. Let's look at the corner points. It has corner points. See, it's got corner points at, oh, let's see, right there at 3, -2. I've got another corner point at 3, 4, right? I've got another corner point at -2, 3. And I've got one last corner point at -2, 4. Okay, so there's my corner points. We're going to talk about corner points tomorrow, but you know, I mean, why even have corner points? But specifically, I'm going to go ahead and talk more about corner points tomorrow, okay? But they're easy to find. It's just there, 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 and there, okay? How's that? Thumbs up? Victoria, can you see it? How's that? Oh, that's too far up, right? There you go. Okay. You guys good? Carrie, turn the page. Nope, not yet. Okay, I'll wait for you, Jen. Absolutely. All right. Turn the page. All right. Oh, well, look at all these words. Blah, 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 blah. I know, we love story problems. Problem with story problems, there's just too many words. So let's read through it and see what's going on, okay? Let's see if we can make any sense out of it. Okay, so a polar expedition is 240 miles away from base camp. And a snowstorm is predicted to reach the area in 48 hours. The expedition will travel as far as possible by boat and then walk the remaining distance to camp before the storm hits. The explorers can navigate the boat through the ice at a rate of 12 miles per hour or walk with the equipment at a rate of 3. Okay? Write and graph a system of inequalities that can be used to determine how long the explorers may travel by foot or boat. Okay, so we're looking for two equations, right? So we're looking for two things, right? So, Jocelyn, what are two things that might be in this situation? Two things. What's two things that might be going on? Go ahead and read it. What do you think? Two things, two situations that's happening. Two things.
There's a snowstorm.
There's a snowstorm, right?
And they're trying to travel.
So they're going to travel. How are they going to travel?
By boat and walking.
Okay, so let's go ahead. We got beef, we got boat, and we got walking, right? I agree with that. Okay, so definitely got a boat and walking. We've got that. So let's let X be the walking. I'm going to let the Y be the boat. You okay with that? Okay. So one equation, I'm pretty sure, is this. X plus Y, okay? Now, they're going to walk for so many hours. They're going to go by boat for so many hours. But if they're out more than 48 hours, they're in trouble. Okay, does that make sense? So let's say we better get home before 48 hours. Now, if they get home before 48 hours, even better, right? Hey, great, kick back, go to camp, relax. So they could do it less than, right? But I think more than 48 hours, we're in trouble, okay? Now, there's another thing going on in the story problem. Okay, we got time. We've got time in it. So this is kind of a time equation, okay? This one's our time. So many hours walking, so many hours boating. We better get in before 48 hours, okay? There's another situation. What else is going on up here?
You have to go 240 miles.
So we've got a distance or rate type thing, right? A distance. So let's talk about distance and rate. So distance, it's up here really. Distance is equal to rate times time. You guys remember that? Remember that little formula? Some people call it the DIRT formula, but that doesn't sound very scientific. Call it the DIRT formula, right? The DIRT formula. But you know this formula, right? Who drives? Who drives in here, right? So if you drive 60 miles an hour for 3 hours, how far have you gone? 60 miles an hour for 3 hours, you've gone. Yeah, you just multiply, right? We know this formula, right? So it's the same thing, right? Distance times rate. Rate times time equals distance. There we go. So we're going to have the same thing going on. So we're going to have an equation where we're going to walk, but we can only walk 3 miles an hour, right? Plus, we can go by boat, and we can go 12 miles an hour, right? But we've got to go, it's 240 miles away, right? So the problem is that if we walk directly, straight line, boom, boom, straight line, boom, 240. But since we're going to go by boat and walk, it's probably not going to be 240. It's probably going to be more, right? So it's probably going to be greater than or equal to my 240, okay? I mean, think of this. It can't be less than 240, right? It cannot be less than 240 because we know that it is exactly 240 miles away, right? But, you know, it might be more because we might boat a little crooked, we got to walk a little crooked, right? Get up and over ice fields and around things, right? So it could be more than 240, but it certainly can't be less because base camps, 240 miles away, okay? How am I doing, okay? Now there's two other equations that we normally don't write, and I'm going to put those off to the side. The two other equations are, okay, we rarely write these because we know it, right? And what do those two equations represent? Come on, smart kids. Go ahead, Leora.
X and Y both have to be greater than 0.
Why?
Because, well, in this one, you can't really walk or boat a negative number.
You can't, because it's time. It's time out there, right?
And you can't have a negative time.
You guys agree with that? You can have negative time, and you can't have negative distance, right? That'd be silly. So when we graph this whole thing, we've got to stay in quadrant 1, right? Anything, the other quadrants is just irrelevant because that's negative time and negative distance. That's silly, right? Now these are equations you probably never would write, but they are part of the whole problem, okay? So, you ready to graph this? Let's check it out. So, first of all, equation 1, what are we going to do? We're going to solve for y. X plus y is less than or equal to 48. And my other equation is my 3x plus 12y is greater than or equal to 240, right? So let's just solve for y on both, okay? Solve for y. I'll bring over the x, right? I'll subtract it. Y is less than or equal to a negative x plus 48. Oop, that's a 48. Sorry, so sloppy. That's ready to go. This one, bring over the 3x. We'll have a 12y is greater than or equal to a negative 3x plus 240. Divide by 12. Divide by 12. Divide by 12. Megan, am I going too fast? Am I okay? You're just watching. Okay. Y is greater than or equal to a negative 1/4 x plus, I don't know, hold on real quickly. 240 divided by 12 should be 20, right?
Yeah.
It should be 20. I actually should be able to do that in my head. Okay, now, let's see. I got to get all the way to 48. So if I go by 2s, I don't think it'll work. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So maybe I need to just go by, what if I go by 4s? 4s would work. Let me go by 4. 4, 8, 10, let's see, 4, 8, 12, 16, there's 20. 24, 28, 32, right? 36, and there's 40 way up there. So 48 would be there, right? And I do the same thing this way and go, let's see if that's 4, then I go, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, there's 20. 1, 2, 3, 4, 5, there's 40, right? Okay, right? 4, 8, 12, 16, 20, and then 4, 8, 12, 16, yeah. Why does that look different? I don't know. Okay, so let's start graphing what we have. Okay, so let me graph this first one. Start at 48, right? And I'm going to go down 1. Okay, watch this. Okay, I'm going to go down 1 over 1, but if I go down 4 over 4, same thing. Down 4 over 4, same thing. Would you guys agree with that? I also know it's got to cross at 48 to agree with that. It has to cross right here because that would be going straight down, right? But anyway, we'll graph it in. We'll go down 4 over 1, down 4 over 1, down 4 over 1, right? Get it. I'm going to try and do a really good job here. Getting it in. Boom, there you go. Okay, and this one is less than or equal to, so I'm going to shade below. Okay. So what we just graphed was all the different times we could walk or boat. All the different combinations of walking or boating under 48 hours. That's what all of these points represent. It's all the possible representations of the times to walk or boat under 48 hours, okay? Now, is that going to get us there? Well, we don't know because we've got 240 miles to go, so let's graph the other one. So if we graph the other one, we're going to start at 20. Okay, so I'll do, oh, how about I do this in blue? 20, okay, and I'm going to go down 1 over 4, so if I go down 4 over 1, 2, 3, 4, over 16 down 1 over 4, it still works, right? Down 1, 1, 2, 3, 4, 1, 1, 2, 3, 4. Well, I'll do it again. 1, 2, 3, 4, 1, 2, 3, 4, and so forth and so on. Okay, and I shade here. Okay, now this one's greater than, right? So I shade everything above. Okay. Now let me take the two areas that overlap. Just right in here. I'll make that darker than all the rest. That's the green. Okay. So what does the green region represent? What does this represent? Represents being able to get it done under 48 hours and still go 240 miles. Okay? So the green represents being able to finish under 48 hours and get 240 miles away. All the different combinations. Okay, all the different combinations. So, real quickly, I'm just going to pick a point, and I'm almost done. How about this point right here? I'll just pick this point. So that means I could walk for 20 minutes, boat for 20 minutes, and still make my base camp, right? Does that make sense with that point right there? It means I could walk for 20 minutes and then hop on the boat for 20 minutes and still make my base camp, okay? Got it? Okay, so here we go. It's not that much, 202, 3, 5, 7, 9, 26, 44, 48. Please show work, all right? Yes, of course you can.